Section 3.
Почти.
Yeah. So every acceleration is because of some net force. If an object has an acceleration, absolutely it must have some net force. So when an object is on a circular path, it has centripetal acceleration there, so there must be some centripetal force acting on the object. Okay, so this centripetal force can be a single force, just one force. It can be gravitational force, friction force, normal force, electric force, magnetic force, single. Or it could be resultant. Yani more than one forces, resultant effective force, on a body that moves in a circular path directed to the center of the circular path. Yes, because Fc and AC, according to Newton's second law, they must have same direction. Because when you multiply a vector by a scale, the result is a vector again. These two vectors have same direction. AC and FC. What is the angle between them?
0.
Yes. This is, I think, Mr. question last year. Yes, what is the angle between FC and AC? What is the angle between VT and FC?
90.
VT and AC?
90.
Yes. Magnitude of this force can be found by Newton's second law, Fc is equal to m times AC. Instead of AC, I can insert VT squared over R. Or I can write instead of AC R omega squared, and I can write two alternative forms of centripetal acceleration. And these are the questions about it. Yes, sir.
V2 FC is 90.
Yes, only.
VT alone?
VT tangent.
Oh.
AC towards the center. Angle between them is 90 always. AC and VT.
VT squared over R and best VT.
But VT squared over R, how we calculate magnitude of AC? It's not the direction, it's not about. I didn't put like this, look at that. AC is equal to VT squared over R. Did I put an arrow in here? No. It's just about magnitude, how the magnitudes are related. It makes sense because if VT increases, direction change becomes quicker. That's why AC increases. They are related in magnitude. Now, short response. Question number 10. Very important question. Are the bodies that move in a circular path in equilibrium? What is equilibrium? Do you remember chapter 2? Net force acting on the object must be equal to 0. Tell me, net force acting on an object in a circular path 0? Is it 0? No, resultant effective force. There's a force, net force. If there is no net force, what happens? Object follows straight line path. Remember the law of inertia. So that's why object moving in a circular path cannot be in equilibrium. It's not. Because net force is not 0. It's not 0. Other questions are easy questions, just problems. Find FC, VT given, R given, M is given, and VT squared over R. Find what is FC. In here, FC is given, M is given. This is the point, 3.25 kilometer circular track. It is the length of the circle, not radius. From here, we will first calculate
2 pi R.
2 pi R, yes. Then after that, we will find VT. This problem, all these parts are important. Don't. Write this R. Other two problems, masses are asked in both of them. Yani in the equation, M is questioned. What are given? VT is given here, VT is given here, R is given here, force is given, mass is asked. It's true. Last one is an airplane flying in horizontal circle at a speed, tangential speed is given, mass is given. This pilot does not want centripetal acceleration to exist 7 times for full acceleration. Remember, this means centripetal acceleration is going to maximum 7 times 9.81. And it's defining AC. AC is given. Find R. Find R. By which equation?
VT squared.
Yes. Only instead of AC, you are going to write 7G. Yani FC is going to be M times 7G, 7 times 9.81. Additionally, what is net force? What is net force that maintains circular motion defined? FC. M times AC. AC 7G multiplied by M, which is FC. Application of centripetal force. First application. First, we know that definition of the centripetal force is it can be a single force. If it is a single force, it was okay. Just mv squared over r, or mr over k squared is FC. But what if there are more than one force x on it? We will calculate resultant. Resultant effective force. Resultant, but also effective. Remember, I defined the force effective and ineffective. Ineffective forces are perpendicular to radius. We don't count them. But the forces along the radius, it can be towards the center or away from the center. We are going to find the resultant. So what is the resultant of these two forces? Because they're opposite in direction, we are going to subtract them. So F1 minus F2. This is if two force x on the object in the opposite direction, the force pointing to the center always greater than, maybe then away from the center, because net force, resultant force, which is the centripetal force, must be towards the, in this case, F1 must be greater than F2. So this is one of the questions, also last year they asked this question in ministry. So at this position, which force is greater? F1 is greater than F2. How can I calculate the resultant? F1 minus F2. But if this object comes in here, what happens? Last year they asked us.
F2 is greater.
You can't compare them, because in here we can compare, not at the top. Because at the top they are in the same direction. FT and FG both are in the same direction. FG and FT both are in the same direction. How can you compare it if they are in the same direction?
Teacher, aren't they zero? No, we'll
No,
add them.
we'll add them. So this time FC is going to be FT plus, this was last year's first time asking this question. So, and this case is about, this case there are 1, 2, 3, 4, 5 questions. Yeah, well, they're not exactly the same, but similar to each other. One of them is this one, as I said. Which one is greater? Tension is greater than gravitational force, because F1 is tension force, F2 is
Gravitation.
so FT is greater than FG. Question number 1. Question number 2 is about roller coaster. It's also vertical circular path. This is vertical circular path. This is vertical circular, but slightly different. When a car is moving on a track, which is the roller coaster car, above, again two forces act on it. One of them is gravitational force, always downward. But second force in here is the normal force by the track. Track is below, normal force must be acting upward direction. Now if I ask you, if this object is moving on the circular path, now which force should be greater?
FG.
FG, because it's pointing in the center. The one which is pointing in the center must be
Greater.
greater. In here, FT was pointing in the center, it was greater, but in here, FG pointing in the center, FG must be greater. And it is less than FG. So, this question is saying you that if I put in here, it's different. When the car is passing from this point,
FN is greater.
this time Fn is going to be greater, not FG. Fn is pointing in the center now. In here, Fn is greater than Fg, but in here, Fg is greater than Fn. Then the question's solution is easy from knowing this part. Roller coaster car speeds down the hill at best point A, then B. Tangential speed at A is given. In here, Vt is given. What is the resultant force on the car whose resultant force is given? What is mass? So I'm going to choose the centripetal equation, which is mv squared over. So I am going to find this because Fc is given, Vt is given, R is given. We'll find this. Then B part says, what is the maximum speed the car can have at point B for gravitational force told it to track? But at point B, there could be two forces. One force always exists, which you cannot cancel, you cannot remove. You cannot destroy it. which is Fg, but Fn can change, depending on V. When V increases the speed, Fn gets smaller. If V increases, V gets maximum, Fn becomes 0. This case. At maximum speed the car can have at this point, Fn becomes 0, then only one force is left. Which force? Gravitational force. Then at this question, part B, you are going to say that Fc is equal to Fg. M times V squared over R is equal to M times G. And will simplify, you will find how much is this maximum speed, R and G, know for this question. This is roller coaster car, but car is above. But there is one more question. Again, roller coaster, but this time car is turning from below the track. So a roller coaster moves through a vertical loop at constant speed and suspect its passengers upside down. This case, again circle, but this time car is turning like that. Again, two force acts on the car. One of them is absolute gravitational force. It never changes direction. Second one is Fn. But this time Fn is not this way. Because drag is above.
Cut it down.
Downward. Fn is going to this time. Both are pointing in the center now. Roulette down. Fg plus Fn is the centripetal force. It says, in what direction is the force that causes coaster and passenger to merge? Of course, it's going to be towards the center. Towards the center, which is downward. The centripetal force must be downward. But which force provides centripetal force?
FG.
Gravitational force and in here. So, section over. This is the one it is. And question number 22. Because of the Earth's rotation, you would weight slightly less at the equator than would at the pole. Explain why. This case and that case, maybe horizontal, this is vertical circle. But this is horizontal circle. It doesn't matter. Because when an object is moving, and when the Earth is rotating, let me show it like this. When Earth is rotating, your body is in circular motion. Like this object is in circular motion, like this car is in circular motion. As Earth is rotating, your body is in circular motion. Assume that you are in the equator. You are standing at the equator. Again, two force acts on your body. One of them is Fg towards the center of the Earth. The other one is Fn, Fa. So now, which force is greater?
FG is greater.
Which one is smaller?
Fn is smaller.
Why?
Because
of
it
the
is
circular
the
motion. Because of the centripetal force. So the centripetal force makes Fn smaller. And you will weight slightly less at the equator because of centripetal force is maximum, Fn is minimum at the equator. But at the poles, it's not like this. At the poles, your body is not in circular motion. At the poles, Fg is towards the center. Fn is away from the center, but now you are in equilibrium. No circular motion of your body. In equilibrium, these two forces must be equal at the poles. At the poles, you are going to read greater Fn. At the equator, you are going to measure smallest Fn because of the centripetal force. Yes?
Teacher,
Yeah.
at the poles,
Mm-hmm.
Fn is greater than Fg,
No, they are equal at the poles.
but at the equator,
The one which was greater. The one which is pointing in the center.
Fg is greater.
Yes, Fn is less. Astronauts floating around in centripetal are not actually zero-gravity environment. Why do this? That this is in fact not about circular motion, but it's about how Fg and Fn are related. When the space channel is falling with G, you are not in contact, astronauts are not in contact with anybody. You feel your weight by Fn. In fact, when you are standing on the ground, you feel a force acting on your body, which is equal to your weight. Because Fn is equal to your weight. If no Fn, you don't feel your weight. You jump from second floor. So you are not going to feel Fn because your body is not touching anywhere. Like this, when the astronauts are falling with G inside space shuttle, because they don't touch anywhere, push anywhere, any surface, Fn is 0. They feel weightless. Yani feeling weightless means Fn at the normal body is 0. Okay. This happens only if you jump from second floor or you move downward with space shuttle in G with G. Free fall. And this is one of the question types about second question types are very popular one. Friction. Car is turning, bike is turning, you are walking. So all are about friction force is keeping you in a circular path. So if an object is moving in a horizontal circle, contact with flat surface, which force is provided?
Fn?
Fn, is it pointing in the center?
No.
Center is this.
So it's static friction.
Yes, these are ineffective. Perpendicular to radius. They don't. Only static friction force. There are several questions about that in the ministry. So, which is the most direct cause of the car's centripetal acceleration? Static friction force. Identify the force that maintains circular motion of a bicycle moving around flat circular track. Again, static friction force. Car, bicycle, bike, whatever.
Teacher, whenever it says flat
axle, static friction. And there is one equation. Yeah.
Do we use that equation for?
Yes. For these types of problem. Yeah, horizontal, circle, flat surface. This is the equation which we are going to use. Mu s is equal to AC divided by, what is AC? Centripetal acceleration. What is G? Centripetal acceleration. What is mu s? Coefficient of friction between the surface and the object, between the car. Just an example. Car is traveling, Vt in kilometer per hour, you have to convert it to meter per second. Radius is given. Calculate centripetal acceleration AC, which is square over R. Then, what's mu s? Calculate. AC divided by G, that's all. AC will be calculated in A, mu s will be calculated in B. 34. 2,000 kilogram car, round circular cut with radius, road is flat again, coefficient of static friction, this time mu s is given. How fast? Vt. Where is Vt? Vt is inside AC. I can write it. Mu s is equal to G, AC is Vt squared over
R.
You will find this. And mu s is given, G is given, R is given, so why not? This is also a similar one. But a little different. After calculating omega, how? Omega will be found in here, omega final. Of course, for omega final, I'm not going to use Vt squared over R. R omega squared. Yeah, and mu s is going to be R omega squared over G. You will find this omega, but this question doesn't stop in here. This is an accelerated motion. This is final omega. Initially, it's from rest. You get that?
It's 0.
We're going to use kinetic equation for delta t. It says how, after what time interval, omega becomes this number. Omega final is equal to omega initial plus alpha, because alpha is also given in here. These are the questions about this equation. All are similar. And the last case about application. Vertical contact surface. Cylinder rotating, there was a problem. Or another example, which is bobsled, turning the corner. You have vertical contact surface, not flat. What force is providing the centripetal force?
Fg.
Not Fg.
No, Fs.
Fn. Normal force is there. If an object is moving in a horizontal circle in contact with a vertical surface, normal force is the centripetal force, which is the centripetal force. So, identify the force that maintains circular motion of a bobsled, turning a corner on its track. Normal force. And this question is, what happened to the mass equation now in this vertical contact surface? It flipped. This was AC over G. This is
G over H.
G over AC. And again, omega AC is M omega square. You will find omega. Mu S is given, G is given, R is given. So what is omega? It's asking you. Yes, you will find it. Correct? Okay, let's check it. R, angular speed omega, sorry, omega is asked, mu S is asked, not omega. Omega is given. Find mu S. So right, mu S, G is 9.81.
81.
AC R omega squared. R is how much?
3.
Omega is how much? Why don't calculate?
20.
Is it this? That's all. Yeah?
Yes.
Is it okay?
Yes.
Are you sure?
Yes.
You was surprising.
I've
And-
just never seen that formula before. I don't know where.
You didn't see this question before?
Like this formula. That's why I was confused.
No, these are very, very practical. Mu S AC over G. In here, T over AC. Flip version.
Teacher.
Horizontal flips the vertical surface. The equation also flips.
Teacher, if it's a vertical surface, down we'll say mu S G over AC.
Yes, this question.
And horizontal
Don't
surface.
worry, they are not going to ask another question. This is the question only.
Okay, thank you.
They will ask this. And centripetal force and inertia. Centripetal force is the net force acting on an object. So if there is a net force acting on an object, it can follow circular path. What if there is no net force acting on an object? Will it follow circle? No. Natural tendency of an object to follow straight line path. In the absence of a net force, tendency of a ball of any object is to follow
Straight.
That's the definition of inertia.
Inertia. But when we attach this ball to a string acts a force on the ball, which is the centripetal force, causes it to follow. So the string counteracts this tendency by exerting a force on the ball. This perpendicular force, perpendicular to the direction of the velocity, makes the ball follow the centripetal force. As long as the sufficient centripetal force acts on the object follows.
Circular.
But if the centripetal force vanishes, removed somehow, or not as sufficient. In this case, object will not follow circular path. If centripetal force vanishes, object does not continue move. It moves along a straight line path tangent to the circle inside. All these questions are about that. Imagine that you attach a heavy object to the end of a spring and then holding the spring again, whirling the spring.
The tension force.
What happens? The tension force, of course, it's spring force, or we say spring force, chapter 3 will learn that. So which force keeps the object in a circular path? Spring force. But why spring stretches? Because as you rotate it faster and faster, you need a big centripetal force. Omega increases, centripetal force should increase. So which force is centripetal force? Spring force. How can we increase the spring force? By x. K is constant for the spring. But x, as x increases, you remember this spring force? We said chapter 3. It was like this. F is equal to negative k x. This is the centripetal force now for object attached to this spring. If I want this one to increase, say x should, then spring will be stretched if you increase omega to provide enough centripetal force. Another question, why does mud fly over a rapidly turning wheel?
Its inertia is greater.
Inertia greater, let's say that force is not, the force between the mud and the tire is not enough to keep it in the circular path, not sufficient. If not sufficient, of course, tendency of the mud is to follow not circular path, straight line path. This is the answer of all questions. Explain why Earth is bulged, not spherical, at the equator. Because gravitational force is not great enough at the equator to hold the particles in a circular path, so they will move away from the center, and the Earth will be bulged. Why does the water remain in a pail that is well in a vertical path, as shown in the figure? If you move an object with enough tangential speed, omega angular speed, so which is going to be the centripetal force Fg, So in this case, you can keep it. Yani mv square over r should be equal to which is centripetal force? Fg. Then you can keep it inside the pail. But if your speed is less than that, you cannot. As if speed decreases, then if mv square over r becomes less than mg, you cannot keep it in a circular path. It will not stay inside the pail. This is the case. Minimum case. Could it be possible mv square over r is greater than mg? Yes. Yes, it could be possible if it is like this. Yeah, you can make the speed as big as possible, but not smaller than that. If it's smaller than it will not stay inside. This is all about centripetal force and inertia. And last title was Universal Law of Gravitational Force. And until Johannes Kepler, they believed that not Sun is the center, Earth is the center. But Johannes Kepler proposed that planets orbit the Sun. Sun is the center. In elliptical paths. What is ellipse? This is ellipse, not the circle. So ellipse has two focus. One of them is on the right, the other one is on the left. The Sun is where? In one of them. It will be here or here for any planet. So planets orbit Sun in elliptical path with Sun at the focus. And the force that keeps these planets around the Sun is gravitational force. Get that? We just want to discover the planet traveling in elliptical path rather than circular orbit. Right, Kepler. Which of the following choice correctly describes the orbital relationship between Earth and Sun? Sun orbits the Earth. No. Earth orbits the Sun. In a perfect circle?
No.
No. Earth orbits the Sun in ellipse with the Sun is at? Answer. And the force that keeps the planets around the circle, the Earth, Sun is what? Gravitational force. What is gravitational force? It's a field force, non-contact, that always exists between two masses. And attractive, not repulsive. Always attracts. One object attracts one of them, they attract each other. The attractive force. Earth attracts Sun, Sun attracts Earth. Gravitational force is directly proportional to multiplication of objects' masses, and one times, not only one object, all of them. And if the force between Earth and the Moon, Earth and the Sun, depends on Sun mass and also Earth mass. And also distance between them, separation of distance, which we said that gravitational force is inversely proportional to square of the separation, not separation, square of the separation, that's R squared, 1 over R squared. This gravitational force, universal law of gravity, is also called as inverse square law because of that, 1 over R squared. When we combine these two, Ft is going to be G m1 m2 divided by R squared. Now, what is G called? Universal law of gravity. It's the constant which never changes. m1, mass of the first object. m2, second object. R, separation between them. What is unit of G?
Meters.
It was also in this question. Yes. There are problems. Problems are, as I said, not very. These two are calculating about the force. Just write numbers, mass 1, mass 2, and R. These two are about finding distance. R is going to be calculated. Fg, G, m1, m2 is given here. But better to go with this way. First write R equation from here. R squared is equal to what? Capital G, m1, m2 divided by, after that, write the numbers. Otherwise, sometimes you are doing calculation mistake. Yeah, R is the question. Calculate this, and after that take the roots. Then find it for both of them. And the last one, what data do you need to calculate orbital speed of the satellite. And satellites are revolving around the planets, huh? You can get it. You don't need to memorize it, in fact. Earth, for example. Satellite. The orbital speed means VT tangential speed. Why this satellite is following a circular path? Because of gravitational force acting on it. So, planet acts a gravitational force on it. Towards the Earth center. Earth also attracted. But because mass of the planet, the satellite is small, it's in circular motion. So then I will say that which force keeps the satellite in the circular path?
Gravitational force.
So centripetal force is gravitational force. Is it?
Yes.
Okay, write the numbers. Right, calculate VT equation, right? Then VT squared over R, which is the radius of the orbit, is equal to, write FG equation, capital G, mass of planet, mass of satellite over R squared. Now, mass of satellite will simplify. Rn squared will simplify. What is VT squared? Capital G, M over R. Then take to it. VT is equal to root of Gm over R. What is G, universal gravitation? What is M? Planet's mass, not satellite mass. Yani the mass of the object at the center of the circle. Oh, right. So then check it now here. What data do you need? I need to know what is mass of the planet. I need to know what is radius of the orbit. Mass of the planet and radius of the orbit is the correct answer. Oops.
Teacher, you said the Earth is bulged.
Yeah.
What was the reason for that?
It is, as I said, it's at the equator. It's gravitational force acting on the particles or rocks are not big enough, so they move away from the center.
But there's still gravitational force.
But not enough, not sufficient to keep it.
If it's also greater than Fn, like gravitational force is greater than Fn, right? But
Gravitational force is greater than Fn. I'm not talking, Fn acts on my body. I'm not talking about me. I'm talking about the rocks or other things. Okay. There's a short thing. Bunu da bitirelim that there's a short thing. After that we can go. Strength, gravitational force strength. Small g. How can we calculate small g? By this equation. So, free fall acceleration is capital G, mass of Earth or the planet divided by R squared. What is R? From center to where, which point you are looking for gravitational force. If you are in this space, this is R. If you are on the surface, this is R. So what happens if R increases G? Decreases. That's why when you go to space, G gets smaller and smaller. This is one of the chapter 2 question. Comment on this statement. There is no gravity in outer space. Why no gravity in outer space? Because R is increasing. If R increases, G decreases. And finally becomes, zero. What are we looking for? This? Okay. And 2 more questions. Which of the following is the correct interpretation of the expressions G, capital G, mass of Earth divided by R squared? A, gravitational field strength. These 3 explain the same thing. Gravitational field strength, free fall acceleration, acceleration of gravity, they are equivalent. All are defining small g, small g. Gravitational field strength changes with objects. Distance, yes, with R, it's changing, correct? Free fall acceleration changes with object distance, yes. Free fall acceleration independent of the fallen object's mass. Yes, because there is no fallen object's mass, only planet's mass. And which of the following statements is correct? Mass and weight both vary with location.
No.
Mass is the amount of matter, but weight and G. Mg, G changes from location to location. When you go up to the mountain, it increases, for example. Mass varies location, but weight does not know. Weight varies with location, mass does not. I think this is all. For chapter 1.
Thank you.
Okay, now you go home.